Hello, is I'm audible? Sagar sir,
Yes, sir.
Yes, sir.
thank you very much. Good evening, one and all. I am Dr. Muhammad Sirajuddin, co-coordinator of this 6 days faculty development program. I welcomes you all to the day fourth of this online FDP. Now, I take privilege to invite our eminent speaker of today's session, Mr. Ranjit Kumar sir. Mr. Ranjit Kumar sir is an accomplished IT professional with over 17 years of experience in software development, in DevOps practices, and IT infrastructure management, with a proven track record in designing, deploying, and managing the scalable enterprise applications. And he has consistently contributed to streaming development of pipeline applications, and he also expertised in DevOps automation, CI/CD implementation, various cloud platforms, and so on. He's also expert in agile methodologies and makes him a versatile asset in the IT industry. I welcome you, sir. Please over to you, sir. Ranjit Kumar, sir.
Thank you so much, sir. Thank you very much. Hi, good evening, everyone. I'm audible.
Good evening, sir. Your voice is very clear. PPT is also visible, sir. Please carry on.
Yeah, okay. Good evening to one and all. Today, our session is on quantum cryptography. In an action to build the digital world, now it is moving towards a past classical methods to an encrypted method, which is nothing but before we are using classical computers. Now we are moving to the quantum computers. It is nothing but an evolution. In the earlier days, we used to having the Pentium 1 systems. It is nothing but it has a very large transistor chips. And next we have the updated to the Pentium 2, Pentium 3, Pentium 5. So all these are nothing but we are adding the chips, n number of chips into the processor. Every computer must need a processor. For that processors, we need a transistors. Initially, it is a big processor and it has only few transistors to transform the signals. And after Pentium, we have the Intel 1, Intel 2, and AMD processor. Now we are using AMD processor. But our in digital era, we are moving to the very miniature. It is nothing but everyone is becoming a nanotechnology. We are using nanotechnology. For that, we are in computing, we are going to use quantum technology. This is nothing but with the help of the photons. It has an n number of transistors in the module, nothing but a chip. The chip consisting of an n number of chips. Why? With the help of the chips, we can able to process the data. Initially, we have the 8-bit processor. Next, 16-bit. Next, we have 32-bit. Now we are using 64-bit. But with the help of the quantum technology, we can able to use n number of bits. It has a huge number of bits. Recently, IBM has launched its quantum system. It has an 400 bits. When compared to the 400 bits is nothing but billions of data can be transmitted within a second. We can able to transfer the billions of data. Why? Because in our system we will use only the now we are using present 64-bit, but it is a consisting of an n number of bits. It's going on increasing from day 1 to day 2 daily. Present IBM has launched its 400-bit processor, nothing but a 400-bit processor. It can able to solve the very huge complex problems. With our system we can able to solve the problems, but we can't able to solve the problems like complex problems like in chemical industry. In a chemical industry, there are huge number of molecules there which has to react with each other to form the chemical bond. That type of problems we can't able to solve by with the help of our traditional system. But with the help of the quantum systems, we can able to solve all those problems. Here in traditional system, we have only the either one, either zero. It is nothing but if it is on, it is one. If it is an off, it is zero. It is nothing but an transferring the signals to the chip by using the electromagnetic waves. We will pass the signals, either it may be one or a zero. We will use only the binary bits. It is nothing but either one or zero. But coming to the quantum, it has one, zero, and combination of the both one and zero simultaneously. Like when we are tossing a coin, suppose if we toss a coin, it has an one, zero, nothing but if it is an head, it is an head is nothing but one. If it is an tail, it is zero. But in between, it has a probability for the one or zero. In between, when we are tossing a coin, it has the two probabilities. One is heads, one is tails. But before the result, it has the n number of possibilities. Either it may be head, tail, tail, head. Like that processes we have. It is nothing but if it is in a upward position, it is called as a one. If it is in a downward position, it is zero. If it is in between the n number of possibilities, either 1, 0, 0, 1, it is nothing but the quantum bits. If the position is upwards, it is called an 1. If the position is downwards, it may be 0. If it is in between 1 and 0, it may be either 1 state or 0 state. It is called as an superposition state. It may be in a superposition state like 1, 0 or 0, 1, 1, 0, 0, 0. Like n number of probabilities are there. And if there is a combination of 1 and zeros, there is also one more combination called 1 and zeros. It is nothing but an entanglement. It is called as an entanglement for 1 and 0. Two quantum bits can be combined together and form an entanglement. These are some of the basics which we are using for the quantum computing. Now coming to our topic, we have some cryptography, which algorithms they are using and how they were encrypting the data with the help of the quantum. It is nothing. Coming to the slide, sorry. Coming to our session, we will have the fundamentals of quantum cryptography and real world applications across the different sectors and building the quantum secure networks and implementation of the roadmap and further outlook and strategies. We will, in the first session, we will have about the core principles and key technologies of the quantum cryptography. And next, we will deal with the real-time world examples like an government sector, health sector, and financial sector, how it will be used in the government and financial health sectors. Next, we will discuss about the different types of networking technologies like QKD network technology, hybrid technology, and which infrastructure it is using. Next, what is the roadmap to develop the quantum computer? What is the roadmap we are going to use? Next one, future outlook and strategies. Which strategies they are going to implementing for to success in the quantum computing. We have the four principles of the quantum cryptography. One is quantum uncertainty. Next one is the quantum entanglement. Next one is no cleaning theorem. And fourth one is the superposition. Here, quantum uncertainty is nothing but which will using the physics concept, which we are used in the physics during the intermediate or degree. We will have the some Heisenberg uncertainty principle. It will use the same principle. Just if someone want to measure the which state in the quantum, if either it is in upward position or downward position, we will make the use of the quantum uncertainty. Example, let's think like that. If you are trying to measure a soap bubble, if you want to measure the size of the soap bubble, the act of the touching it pop hits Similarly, the about the distribution quantum states, how it distribute the quantum states, like okay, measuring of a soap bubble. Next one is the quantum entanglement. Entanglement is nothing but the if either is a one position or zero position in between there is a one and zero, it is called a superposition. If it is a combination of the pairs, it is a pair of the particle may be possible during the processing the signals. It is called as a quantum entanglement. Here, let us take it two particles are linked, and no matter how much distance in between them, if there is no matter of the distance in between the two quantum particles, they may be communicate with the each other independent of the distance. And next one is no cleaning theorem. No cleaning theorem is nothing but we can make a perfect copy. We can make the perfect copy of an unknown quantum states. If you don't know the state of the quantum, then we will use the no cloning theorem. With the help of that, we can find the which state. It may be in same state or another state. We can find with the help of the no cleaning theorem. For example, unlike a photocopying a document, if you are photocopying a document, a quantum key cannot be duplicated. Quantum key cannot be duplicated. While we are photocopying a document, a quantum key cannot be duplicated. Next one is the quantum superposition. Here superposition is nothing but a quantum particle can be in multiple states. Quantum particle can be in multiple state at once until it has measured. If you measure the distance of the particle, it may be in the same position or multiple position states. Like Schrodinger equation, we will use the Schrodinger equation. Either it may be a live particle or a dead particle until we look into the quantum. And next one is the cryptographic techniques. Which techniques they are using? We are using mainly the three quantum techniques. One is quantum key distribution, and second one is the quantum random number generators, and third one is post quantum cryptography. With the help of these three cryptography algorithms, they are developing the quantum systems. We cannot track these systems. Why? Because there are n number of keys when we are passing the signals. One is the quantum key distribution. First one about quantum key distribution. It is used for the secure communication method. We will use quantum QKD for the security purpose for communication, for securing the communication. That uses the principles of quantum mechanisms to share the encrypted key between two pairs. It is used to share the encrypted key between two pairs. It is nothing but an Alice and a Bob. In quantum, we will call as an Alice and Bob. Here, Alice is nothing but a receiver. One is transmitter. One will act as a receiver. Another one will act as a transistor. Unlike our classical cryptographies, in our classical cryptography, it is not present, which relies on mathematical complexity. Which has a mathematical complexity. We will use QKD for leverage the law of the physics. With the help of the law of the physics, we will develop it. It can be possible by the mathematical, making it as an unbreakable by theoretically and practically. We can't break it by theoretical or practically. It is not possible for hack the QKD algorithm. Why? Because it has using the physical laws, not the theoretical laws. It will be use the physical laws. And QKD allows the user to share a secret random key. It will be share the secret random key that can be used for the encrypting and decrypting of the messages. While we are using the QKD algorithm, allow the two users. It will allow the two users to generate a shared key between the receiver and transmitter. Then with the help of that key, we can able to encrypt and decrypt the messages. It is an security. It is a security for guarantee. It is security guaranteed by the quantum properties of photons. Here, always we will transfer the data in the form of a photons, like nothing but Niels Bohr theorem. In chemistry, we'll have a Niels Bohr algorithm or theory. Whenever the electron is moving from the higher energy state to lower energy state, always the electron will be jump from the higher energy state to lower energy state. Then there is a difference between the energies. That energy is called as a wavelength. With that wavelength is called as a photon. A photon is nothing but when the electron is jumping from the higher position to lower position, it emits energy continuously. It will emit the energy continuously from one level to another level, and that energy is called as an wavelength, and here we call it as a photon. Here always we transfer the keys with the in the form of the photon itself. And here how does the QKD network will be works? How this algorithm is going to work? The most common protocol we will use is BB84. We will use the BB84, which is developed in the 1984. We will use the BB84 protocol, and which was developed in the 1984. And these are one of, I will explain one step. It is nothing but the photon transmission. How the photon is transmission from one state to another state. It is used as an Alice. Alice is nothing but an transmission. Alice is nothing but transmission of zeros and ones. We have Alice and Bob. Here Alice encode the random bits of zero or bands into the photons. Alice encode the bits of ones and zeros into the photons using different polarization. It will use the different types of polarization like horizontal and vertical and diagonal polarization. With the help of these polarizations, it will convert the zeros and ones into the photons. And using the photons, it will use it to transmit the encrypted key securely. It will transfer with the help of the photons, will transmit the key like an encrypted key or decrypted key very securely. If an hacker want to try, the hacker tries to entrap that, there is an presence is detected. It will detect their presence. Example, China has launched a satellite. Do you know? China launched a quantum satellite. It is MISCUS. It is launched a MISCUS satellite to achieve the first international QKD links. It will be distribute all the quantum keys between the two states of China. In China, it will distribute the in between two states. It will be generating the different number of keys. And next one is the quantum random number generator. Our next topic is quantum random number generator. The quantum random number generator is nothing but a device. It is a device used to produce random numbers. Used to produce the random numbers by using an inheritance of quantum mechanics. With the help of inheritance quantum mechanics, it will generate the random numbers. In classical system also, we will have random numbers usually comes from the algorithm called pseudo random number generator. In our classical system also, we have the pseudo random generator algorithm to generate the random numbers. It is nothing but PRNGs, which are deterministic and can be predicted. We can easily able to predict the number with the help of pseudo random generators. But in quantum systems, there are randomness comes from fundamental physics process. It is not a mathematical one. It is a fundamental physical process that is truly unpredictable. We can't able to predict the which number it is going to generate. Like example, it is in a diagonal polarization or horizontal polarization or vertical polarization based on the photon position. It has in three polarization positions. One is horizontal, one is vertical, another one is diagonal. So based on these positions, polarization position, it will generate the random numbers. So your NG provides a true randomness, not like an just pseudo randomness number. And here how it will be work. There are different physical mechanics, but there are most common thing is one is photon detection method. There are n number of methods, but we will use the photon detection method. Here photon is sent towards the beam of splitter. It will split the beams, photon beams like an half silver mirror. It will always send the beam of light like an half silver mirror. The photon has an 50% chance of transmitting and 50% of reflected. When we are transmitting the beams on a silver mirror, it has a 50% chance of transmitting and 50% of chance to be reflected. If detected in one path, the output is 1. If detected in the other path, it is output is 1. Repeating this generating, it will generate the random bits. It will repeat this series. If, if the detected is in one path, it is output is 0. If detected is in another path, the output is 1. It will uses repeating this generates and a stream of random bit will be generated. And classical random numbers are pseudo random and can be predicted. Example, used by the cyber security firms to make an encryption unbreakable. We are using these techniques in cyber security team to make the encryption is an unbreakable. And next one is the post quantum cryptography. It is nothing but PQC. We'll here post quantum cryptography refers for an cryptographic algorithm that are designed to be secured against attacks for the quantum computer. If it is majorly used for the to secure the against attackers. If any attackers are going to attack on our system, we will use PQC algorithms to prevent from attackers. Currently, widely used systems like RSA, DeFi, Hellman, Elliptic, and curved cryptography relies on a problem that classical computers cannot be solved securely. Here there are n number of systems we are using presently. One is RSA system, next one is DeFi system, next one elliptical curve cryptography. It can be can't solve this algorithm. We can't able to solve the PQC algorithm by our existing system like RSA, Diffie-Hellman, and elliptic curve cryptography. But with an quantum algorithm such as source algorithm, with the help of the source algorithm, this schema can be large scale quantum computer. This schema is a very large scale computer, become a protocol. It is a best protocol we are using for to prevent the system from the attackers. Example, it has an NIST is an standardizing. PQC is in standardized by the NIST algorithm for the global usage. NIST is an standardizing PQC algorithm for global usage. And next we will go with the real-time world examples. How the cryptography algorithm is practically used in the real-time applications. We will mainly use this cryptography, quantum cryptography in government and military, financial sectors, healthcare, and critical infrastructure. The best examples of the quantum cryptography algorithm was used in majorly in government and military, financial sector, healthcare, and critical infrastructure like power, water transmission. How we are using in government and military sector. In government sector, it will protect the intelligence. To protect from the intelligence, to get the intelligence reports very accurately and defends our network and defends the nuclear facilities. To protect from the defense network and nuclear facilities, it will facilitate all the nuclear problems. If you would detect any problem by using the nuclear, now every country wants to generate a nuclear bomb for every country. So that to secure from that, many countries are using the quantum computing. For example, USA uses DOTS quantum security. Here US intelligence team is using the DOTS quantum security to it will achieve to the 99% of uptime. It was always the systems are in uptime. That is nothing but 99.9% with the help of QKD algorithms. It will uses the QKD algorithm to keep their system. So uptime. Next one is the in financial sector. In financial sector, we will use for the internet banking transfer. while we are transferring the any amount, or we are transferring any transaction, while during the any transaction, it must be an very secure. It should be in real time. We should have to provide always real time security for the banking sector. It will uses high frequency trading. It has using the high frequency trading and payment networks. Example, the Bank of England. Bank of England uses its systems to secure with the help of the QKD algorithm with an 302 billion dollars for transaction daily. It will transaction daily amount of an 302 billion dollars. It will daily do a transaction of 320 billion transactions daily. And to secure their system, Bank of England used pilotly QKD algorithm to secure their systems. And next one is in healthcare. In healthcare, we have the majorly to protect the patient's data and clinical research. We have a huge amount of patient data and clinical researches in healthcare system. Example, there is a Mayo Clinic Secure. Mayo Clinic secures 14.6 PB of data. It will not in the TBs, it will be in PB of a data with a quantum encryption. With the help of the quantum encryption, it has storing the all the patient's data in their system. And next one is the critical infrastructures. Critical infrastructure is nothing but in the power, water, transportation system. We are also using the quantum encryption in power, water, transportation. It's nothing but squad systems in a grid. In water department, we have a SCAD systems in a grid for the water plants. To plant the waters using quantum secure networks. With the help of the DAT system, we will secure the quantum secure networks. Example is an NYC water system. There is an NYC water system uses QKD algorithm to secure their facilities. It will transport the water of 8.8 million people daily. It uses the quantum technology to transfer the water from one area to another area. It is nothing like 8.8 million people are using it. It protect that water system with QKD algorithms only. And our next topic is this, how we will secure the cloud and data centers. In QKD, secure the connection between the one data center to another data center with the help of the QKD. It is nothing but an hybrid system. It is a combination of the classical system and a combination of an quantum system. It is called as an hybrid system, or we can able to connect with one data center to another data center with the help of QKD secured connections. We will use the QKD. Why? Because QKD is launched by the China's. It is first satellite of a quantum satellite. It will distribute the quiz. And next one is the quantum random number generator for encryption to provide the better encryption for the transform the data from one data center to another data center, or from one person to another person, or to perform one transaction to another transaction. We will use the quantum random number
Sir,
generation. It is
sir,
not a mathematical one. It is a physical one. No one can able to crack the encryption, or no one can decrypt that numbers. It is not possible.
sir, sorry to disturb you. There is a disturbance in your
Okay.
voice, sir.
Okay, okay. Now is audible? Is it clear, sir?
Yes, sir. You can proceed.
Yeah, okay. Can I continue? With the help of the quantum random number generators, it has an high secure for the encryption. It with the help of QRNG algorithm, it will produces n number of random keys. We can't able to encrypt or decrypt that. If we transfer the encrypted data, we can't able to decrypt unless until and unless Alice and Brock will has to communicate with us with each other. They will transmit the key. With the help of that key only, we can able to decrypt or encrypt the data. Here, data center links via the QKD algorithm channels, and for the secure store data, we will use PQC algorithm. We will be used for connection from one data center to another data center. We will use an algorithm called as an QKD algorithm for between the two channels or two data centers. And to store this data security in the to store the data secure in the data centers, we will use the PQC. With the help of PQC, we will secure the data in data center, and we will integrate. Here, the cloud servers will always integrate with the QRNG algorithm. It will help of QRNG algorithm. We will strengthen the encryption of the data centers more. We are all on top level. We are using QKD, and we are using QRNG algorithm, and we are also using PQC algorithms for encryption and to protect the data securely. Here in industry, with the help of we can't we can able to secure the data from the attackers by 87% by using all these algorithms. Cloud technologies are reduced the cyber risk. We are reducing the cyber risk by the 87 percentage. In globally over all the data centers. In all data centers are using now these algorithms, and 87% of risk was reduced by adopting all these three algorithms. Here, these are one of the companies using now. One is the Cisco Cloud Secure Technologies, one Sarshin. And before only we have discussed that how it was used in the healthcare system, power grid system, and water system. In water, we are also using the QKD algorithm. 27 facilities are serving 8.8 million of residents with who are transferring the water from one person to one other person, one area to another area. In America or USA system, it has using QKD algorithm for the transmission of water also. This is the graphical representation of how it was increased from day to day. In healthcare and defense system, initially it was in greater than 30%, and in defense it has a go for than reaching the 90% of the defense system is using the quantum algorithms. In banking, it has an 30% of users are using this algorithm, and in financial system, mainly it was using in the financial system, it has reaches of above 60%. In healthcare, compared to the both the two sections, it has using the very less number, and in critical infrastructure, it has also going somewhat increasing the level. And cloud providers also nowadays using the all these quantum algorithms. And now we'll have the section 2. It has the how we are securely networking, how we will securely communicate with each other. in secure networks, in our networking system for providing the security, we are using the quantum building blocks. We are using the quantum building blocks. The major components are Alice. Alice is nothing but a transmitter. It is used to generate and encode the quantum state. In which state it may be in. It is in a to generate the state. If in same state it is in one, it is in other state, the output will be zero. And one is next one is the quantum receiver. Quantum receiver is nothing but an Bob. Initially I said there are two things. One is Alice and other one is the Bob. It is used for what is act as a transmitter and other one is acting as a receiver. And here Bob will detect and measure the quantum state. Here transmitter will be generate the quantum state. It will be 1 or 0 and it will detect. With the help of the Bob, it will be detect in either which position it will be in. It will be in either 1's position or 0th position or in 1 0 or in superposition. It may be in same state or the different state. And next one is the quantum channels. Here quantum channel is nothing but fiber optics, satellite or in a free space. How we are using our QKD algorithms in fiber optics, satellite, and the space research stations. And next one is the classical channel. For with the help of the classical channel, we will use it for the verification and synchronization of purpose. Next one is trust the nodes and key management. And now we'll see how we will be using in the QKD in different types. In fiber-based algorithm, in fiber-based you use the QKD. It works up to 120 kilometer range. It in fiber, it may be transmit the quantum from it nearly 120 kilometer range states. And next one is in satellite based, it will be used globally, but it is very costly. In a space, it is up to the 20 kilometers. In state, free space state, it is in 20 kilometers. And major implementations are, it will be majorly implemented in China. China is using the QKD. It's the world largest network system. It is world largest system is in China's one. It is Miscus. It is using the 2000 plus kilometers. It is used for distance of an 2000 plus kilometer distance. It will be transmit data at one time. And next one is in EU quantum infrastructure. EU quantum infrastructure uses the multinational countries or multi-country initiative. It is an initiation taken by the quantum infrastructure of EU quantum infrastructure. And for the research and focus pilot, we will use USA DARPA quantum network. For research purpose, we will use USA DARPA quantum networks. Here we have some major challenges. While using the quantum key distribution network, it has a few challenges. One, the first one is the costly. It is very high cost. Depend why? Because the quantum chips are developed with not a developed with the silicon material. Our basic chips or with semiconductors are developed with the help of the silicon material. But when coming to the quantum chips, it is developed with the help of the gold foils. With the help of the gold, we can able to we can make the chips. And moreover, it is a very huge challenge to keep the system in a position that 0 degree centigrades. We have to maintain the temperature of 0 degrees temperature or space temperature. For the temperature, we have to use to maintain the temperature. We have to use the chillers. Chillers is nothing but a cooling system. With the help of the cooling system, we will cool the all the system to maintain the -degree centigrade or very coolest temperature. Why? Because it will generate the lot of heat. Lots of heat will be generated by the quantum computers. To run that computer, we should have to make the computer in very cool position. It is nothing but the -degree centigrade. So we should have to maintain the space temperature. And next one is lack of integration in existing classical network. We can't able to integrate with our classical system. If there is any existing classical system, we can't combine with both classical and our quantum system. And lack of global standard. Now only it is coming to the development process. There is no globally standard for the quantum systems. See here, the comparison of the range is typically in 5 optics, the KKD uses 80 to 120 kilometers without the quantum repeaters. There is no repeaters. There is one more concept as a repeater. We will see the next slide. Without any repeater, it can be directly transmit 180 to 120. And key rate is 1 to 10 Mbps within a short. And within a short distance, it will be transfer the data of 1 to 10 Mbps. And in satellite based globally coverage, it will be cover globally. It is satellite until this satellite which it is sorry. The satellite based is nothing but the satellite can cover the global range, right? Because it is in this space, it will cover all the range. Next one is the space. In this space, it can up to be 20 kilometer in clear condition. If the condition is very clear, it can able to transmit the quantums up to the 20 kilometer range. And the key rate is variable based on the atmospheric condition. Based on the atmospheric condition, the rate of transmission will be also change varies. And advantages, it will be rapid deployment. No fiber infrastructure is needed. Now we are using the fiber infrastructure for the space optical QKD, but with the help of this technology, there is no need of fiber in quantum computing. And this slide shows the security architecture, how the security is provided. Quantum key distribution has an AES symmetric encryption. It will uses QKD uses AES 256 symmetric encryption for the security. And for quantum random generator numbers, we will use PQC algorithm. PQC for quantum numbers, and post quantum cryptography algorithm, we will use an hardware secure model. It is nothing but HMS for conventional network security. For QKD, we are using A256 symmetric encryption, and for the random all the three things we are providing the security for our computers. And this is the 1000 plus kilometers. Before only we had a say China is the first thing which has launched is the quantum computer or first satellite, quantum satellite, which is the range of 2000 kilometers, and it has 32 trusted nodes. It has n number of nodes. We have only 2 nodes, but here it is using nodes, and it is using for the governance and financial sector. It is mainly using in the government and financial. It is 40 years. It has two systems. One is DARPA and DOE for the quantum networks. It has used mainly for the. It has been completed by 2025. These are the challenges we will face with the deployment. One is the distance limitation. Here the current 100 kilometer per without repeaters. Without repeaters, we can transfer only up for the 100 kilometers. And other one is the cost factor. Why? Because it is specialized hardware cost, and we will use the gold material for the chips development. And next one is the we have to lack of implement the quantum system in any way, everywhere. Now we are using mainly in European countries. One is China, one is USA. And this is the roadmap to implement the quantum system. We should have to follow these implementation. First one is then assessment phase. We should have to conduct the audit and which cryptography we have to need, and we have to identify the risk. What are the risk factors we will face in the first phase? It is to conduct the assessment. It is for the, we should have in that assessment, we should have to conduct the audit cryptographic systems. We should have to conduct the auditing for the system, and we should have to identify the risk. What are the risk factors we will find in the quantum assessment? And next one is the strategy. We should have follow this some strategy for the development, and to find the budget. We should have to find strategy for the budget. Why? Because it has an huge costly thing. So for that, budget is the one of the major problem. For that, we should have to follow one strategy, and we should have to pick up the vendors. We should have to pick up the vendors and plan the deployment. We should have to plan the deployment. Next phase is the pilot. It is nothing but the deployment or test-based deployment. After developing this system in the second phase, we should have to follow the pilot for testing the computers, or the we should have to deploy the system. And next stage is the scalable state or scalable for deployment. The infrastructure has to be expanded to development environment to the deployment environment. In this phase, we will move the system from deployment stage. For that thing, but it is a moving from development stage to the production stage. After completion of the testing, we should have to move it from the development for production. And we should have to continuously monitor the system. We should, after deployment, we should have always monitor the system after deployment. Why? Because if there is any bugs are going, any compliances, any technical issues, for that we will use the continuous evaluation for monitoring. And next one is quantum security assessment. We should have to conduct the cryptographic inventory before starting of the development of the system. We should always collect the which cryptography, and we should have to store all the data in a document and identify the vulnerabilities. We should have to identify the vulnerabilities in algorithm. Suppose if there is any previous algorithm, we should have to identify the vulnerabilities, and we should make a plan to overcome cryptographies algorithm. If there is any dependency, what has to identify? We should also identify the risk priority. Based on the priority, we should have to identify the risk. If the priority 1, it is a high risk. If the priority 5, it is low risk. For the priority 1, we should have to make it first. And next one is the capability. Identify and train the requirements. We should have to train the model or train the system for what we have documented in the first step. And next we have to assess the vendors. For the day, we should have to assess the our vendors to the system and review the process. Here is the future outlook of the quantum security evaluation. How the system is providing the security in future. This is the outlook of the future outlook, which is one is the near-term deployment, second one is the long-term deployment, and third one is the medium-term deployment. Here in near-term deployment, we will use as NIST and PQC standard. The NIST and PQC standard and PQC standards to finalization and implementation purpose. And we will use the Metro QKD networks. We will use the Metro QKD networks in major financial centers. If it is a financial system, We will use the metropolitan area QKD networks in major finance system. It will take 1 to 3 years. And second one is the medium term deployment. It will takes to 3 to 7 years for the developments. It takes the 3 to 7 years for development, and it has been used in the satellite QKD. It will be used in satellites QKD. And the chip scale is also, we will use a QKD chip scale device in medium term development. And we will follow some standard for the network protocols. We have in our computer network also, we have some basic protocols for networking. For in quantum also, we should have to standardize. We should have to standardize some network protocols for for this. And next one is long term. Here long term development takes for 7 to 10 years. 7 to 10 years it will take for 7 to 10 years. And quantum internet, with the help of the quantum internet, it will provide the end to end entanglement. With the help of entanglement is nothing but it has two or more, we can able to communicate with the two or more pairs of quantums or qubits. We can able to combine one or more qubits together. In there will be no distance matter. So for the combination of that bits, there is no distance limitation. For to if you want to extend that, we will make use of the repeaters. We will make use of the repeaters, and we will extend the network also. Here, quantum security is already production ready. Now, the quantum was used in the many of the companies like IBM, Google, and one of the startup. Now, recently, I know that one of the startup in the Bangalore also started developing the quantum computers. It is a hybrid approach. Now, we are in an era of development stage. Already, the quantum here the two type system. One is QKD and PQ solutions are already deployed in today's environment. We are using QKD and PQC systems, and it is an hybrid essential approach. Quantum computing and classical technology provides the defense in depth and manage transaction risk. Majorly, we are using in the military. Why? Because we should have to detect the risk from the our enemies. What are the risks, or how they are launching the bombs, or now they are using the drones. To identify that, we will be mainly using the QKDs. And start planning now. If you want to begin the any quantum computer developer, we should have to first begin with an assessment, and we should have to have a strategy, and then we have to develop, and then we should have to deploy. It takes a few years. It not complete in one day. It takes years to develop the quantum computer. Now global is accelerating. It is nothing but every country and every nation wants to develop the quantum computer. With the help of the quantum, the communication system becomes more reliable. The communication becomes more reliable, and it can creating the both opportunities and competitive pressures. It is one of the huge problem facing by the every country. Every country wants to develop their quantum security system. Why? Because no one can able to encrypt or decrypt the system. Why? Because it will generate the random numbers. It has an n number of probabilities or n number of bits. We can't able to crack that. And next one is security transformation. Here quantum is an security purpose. It's just upgraded the system, the fundamental transmission of how we will protect the sensitive information in post quantum era. Now we can able to easily hack the systems by using the brute force algorithm. But in upcoming era, we can't able to crack the quantum computers. With the help of quantum computers, we can easily hack the traditional data, but we can't able to crack the quantum data. Why? Because it has an n number of keys, and it will has using QKD and PQC algorithms. we have one more topic. Previously, we discussed about the different types of cryptography algorithms we have used in the quantum network or quantum security. How we are providing the security and how each country has using the quantum computer and how much time we will require to develop the quantum computing. Now we are going to see about the quantum repeaters and quantum internet. These are the next generation network. We will use the quantum network. Before we did not see about the quantum repeaters. Why? Because it has using about the short range. It is 20 kilometers or 2000 kilometers. Now with the help of the repeaters, we can increase the range of the quantum or photon. With the repeaters, we can change the distance. We can enlarge the transmission range from shortest to the longest distance. In this session, we discuss about the quantum cryptography and secure networks. Now we will explore about how the quantum repeaters solve the distance limitation. Before we have the distance limitations, now we will eliminate. Now we will eliminate the distance limitation. How the way for the global internet, how it was for the possible for the global internet. Just a second, one second, my system was hanging. The first problem is the distance limitation. There is a distance limitation communication between the one quantum to another quantum. Here, previously we have distance limitation. Now we will overcome this distance with the help of the repeaters. The first one is we have the three limitations in quantum communication. One is photon loss, one is coherence, decoherence, one is cloning theorem, no cloning theorem. Here, what is the photon loss? In our optical fiber, loss is about 0.2 dB per kilometer. After that, it has range of 100 kilometer per range. The signal weakness is too much. If the photon losses, it loses an amount of 0.2 bits per kilometer, and after that it may be a range of 100 kilometers. With that, there will be a signal weakness too much. What is by decoherence? Coherence is nothing but the quantum state that fragments and collapse well distributed by the environment. It will be with the help of the environment. If there is any disturbances while transferring the photon, photon is nothing but a wave. It will be transmitted in the form of the waves. If there is any disturbance in the environment, it will interact the quantum. And next one is the no cloning theorem. Here quantum signals cannot be copied. In no cloning theorem, it's cloning nothing but copying. Quantum signals cannot be copied or amplified like our classical ones. In our classical system, we will use the amplification technique. With the help of the amplification technique, we will convert the data into the binary like ones and zeros. It is in a binary bit. We will use ones and zeros for amplification. With the help of the amplification, we will transfer the signals. And how will be it impact? Without repeaters, QKD works only between the 80 to 100 kilometer range. If there is an repeater, we can increase, but without repeaters, the photons will be transferred up to a distance of 80 to 100 kilometer. It is now we are running the internet and Wi-Fi using the Wi-Fi routers. We are using the to run the internet. We are using the Wi-Fi routers. That one only cover the total area. With the help of the Wi-Fi routers, we are extending our network. but we can't scale it globally. With the help of the routers, we can't scale it globally. Example for the photon loss and decoherence and non-cloning. Here, photon loss is nothing but in standard fiber communication, in standard fiber telecom, after 100 kilometer, after the range of 100 kilometer, if you are transmitting any beam of light in optical fiber, it will only transfer in 1 in 1,000 photons, 1 in 1,000 photons for 100 kilometers. It serves the 2 week of the QKD distributed systems. It is very 2 week. Why? Because after every 100 kilometers, only in 1 in 1,000 photons, 1 in 1,000 photons can be transmitted. Survives for the 2 week of QKD. If there is a photon loss, there will be weak transmission of data. And next we have decoherence. For example, in Tokyo, QKD field test. It has conducted a test in 2018. 2018, it has conducted a test for weather condition. To identify the weather condition, it has an
Sir,
implemented
sorry,
QKD.
sir,
Hello?
Ranjit sir,
Yeah.
sorry to disturb. PPT is not visible, sir.
Oh, sorry.
Check it, please.
It has time. Just give me seconds. Now is it visible, sir?
Now, okay, sir. It is visible now. Please
Yes.
continue.
Yeah, okay. Here the example for decoherence. In Tokyo, they have conducted a QKD field test. While conducting the field test in 2018 for weather condition, weather conditions, based on the weather condition, it was in disturb. There will be disturbed in the signal loss. There was signal loss within a hours. Why? Because based on the weather condition. Why? Because we are transferring the data in the form of the waves. It will be can't transfer the directly. Why? Because if there is an air, any disturbance or any obstacle in front of it, there may be coherence. For that, it will not able to transfer the data. For that purpose only, we will use the repeaters for the long range. And next one is no cloning. For example, unlike 4G and 5G networks we are using on the towers, the network we are using 4G and 5G towers will be using the amplifying signals. We will use the signal called technology called as amplification. With the amplification, we will transferring the network to our mobiles. We are using 4G and 5G network with the amplifying technique. In quantum signals can't be boosted. Why? Because quantum signals can be boosted. There is in China there was a research phase conducting in Beijing to in 2016. For this, China has conducted the test in 2016. With the help of the quantum signals, we can able to transfer the network without any repeaters. We can transfer the network by using quantum, but unfortunately they faced an issue. Why? Because within the short range they can able to transmit the data with help without the repeaters. What are the ranges, current range limitations? Here QKD will maximum output of 80 to 100 kilometers through fiber optic cables. With the help of the fiber optic cables, we can transmit the range of 80 to 100 kilometers through the fiber optic cables. This is the one of the fundamental limitation. This is one of the fundamental limitation. And in satellite, QKD will be extend the range, but it is limited by the weather condition. Previous session only we have discussed that based on the weather condition in the satellite, the satellite also cover the range global. Actually, it will cover the global range, but based on the weather conditions, it may be limited. For that, we have the security vulnerabilities. Without any repeaters, we can't transfer the data for high range. Why? Because based on the weather conditions, it may be affected. Here, the global quantum secure networks are impossible with direct transmission. We can't transmit the data directly without any transmitter or without any repeaters. Example, China launches a Mesius satellite. China launched the Mesius satellite in 2017 that was enable the intercontinental QKD between. It has distributed the keys between the two states. One is the Beijing and next one is Vienna. But only at a night time. We tell about the night time only they can able to see the or they can able to transfer the data correctly. But during the daytime there was an huge weather conditions, they can't able to transfer the data for the large range. With the help of China has already launched the quantum satellite in 2017, but it was not fully success. During the daytime, they can't able to transfer the data, but when it is a night time, it can text very clearly without repeaters. Why? Because it has directly launched the satellite. There is no repeaters in between the ground station to the satellite. Without repeaters, the ground fiber will be linked maximum up to the 100 kilometers. It is a too short for globally. It is too short range. Next, now we have introducing the quantum repeaters. Here, the quantum repeaters will avoid the limitations of the transmission range. Without any trans repeaters, we can't able to transfer the data for the large range. For that, we are introducing the quantum also. We are using the repeaters with the help of the technology called entanglement. We will use the entanglement technology for the quantum repetition. It is nothing but it will swap the quantum bits with one another. One another, it will transfer the bits. Here the definition is it is a specialized device. It is nothing but one of the specialized device that can extend the range of the quantum communication without breaking the quantum rules. Here this repeater is nothing but a device. It is used for the extend the range of quantum communication, but it will not break the any quantum rules like our Wi-Fi router or Wi-Fi extender. With the help of the Wi-Fi extender, we can extend the range of our Wi-Fi. In the similar way, if you want to transmit the data with the help of the quantum, we are using the quantum repeaters, but it will not break the any quantum rules. And here how they are differ from the classical repeaters. In classically, we are using the amplifying signals. In our classical computer, we will use amplifying signals, whereas the in quantum, we will use the entanglement swapping and quantum memory. We will with the help of the quantum memory and entanglement swapping technique, we will extend the distance. We are extending the distance with the help of one is the quantum memory and one is entanglement swapping. It is nothing but combining one or more quantum bits or qubits. We will combine one or more bits. It may be in the same state or it may be in different state. We will combine with the help of an entanglement technology. There is one analogy. Imagine that we are sending a secret to the multiple couriers without any one of them opening it. If you are sending any courier, that should not be opened by anyone. This message has to be reached directly to the person who we want to send. But if there is any repeater, if there is any person in between that while transferring the courier, it may be they can be able to see open the letter and they can able to read the data. But with the help of the repeaters, it is one of the security we should have to provide. Why? Because there is any repeater. It may be the break the rules. But in our quantum technology, we will provide one rule for that is called as an entanglement and quantum memory theory to provide that security. Example, in a Harvard University 2020, a demonstration on NV center by using the diamond effect. It has used the NV center. And next one is the one of the university in the Netherlands. It built an entanglement bridges. It has built the constructed the entanglement bridges between the two nodes. It has between the two nodes to transfer the data of 10 kilometers range apart. They had conducted one small example for that entanglement. For it will be two labs. In between the two labs, they have conducted the entanglement swapping technique, and they have transferred the data at the 10 km apart. And next, we will see the how the quantum repeaters will be work. Here, how the quantum repeaters work with one is entanglement distribution. Next one is quantum memory storage. Next one is the state of the measurement, and fourth one is the error connection. Here, entanglement distribution. What is my entanglement distribution is nothing but adjacent nodes will be generating the entangled photon pairs. It will make a pair of photons with adjacent one. With the help of the adjacent photons, it will make a bond with the adjacent one, and it will be range of the 50 to 100 kilometers apart. With the help of the entanglement pair adjacent one pair of photon will be combined with the another pair of photon with the adjacent repeater station. It will be transferred for 50 to 100 kilometers apart. Next one is the quantum memory storage. Here, quantum memory storage, it will store the data. It will be stored the data of in the form of the qubits. Stores the quantum state position and memory in the form of the qubits. Next one is state of the measurement. While swapping, there will be individual which position. To identify the position of the photon, we will use the well state measurement. Swap, it will be used for the swap entanglement between the distinct nodes. It can also able to form the pair between the not only adjacent node. With the help of the distinct nodes, we can able to combine with the help of well state measurement. With the help of well state measurement technique, there will be swapping entanglement between the adjacent nodes. Non-adjacent node, it's nothing but distinct node. If you want to perform any pair of connection between the non-adjacent nodes, we will use the Bell state measurement. Next one is the error connection. It will remove. Error connection is nothing but it will remove the noise or any disturbance, maintains fidelity. It will be removes the noises. With the help of error connection techniques, we will purification purpose. With the help of the error connection, we will purify the data. If there is any disturbance or any loss of data, we will check in the with the help of error connection. And next we will say what is by entanglement and swapping. What is by entanglement and swapping technique? Here the concept is nothing but two particles. The two particles that never interacted become entanglement. It should not be there is two particles that will be never interacted without entanglement becomes an intermediate measurement. We will use a concept of two particles that has never been interacted with one another. We will make an entanglement via an intermediate measurement. With the help of the intermediate measurement, we will interact with each other. Next one is the security benefit. It is will be end-to-end encryption. It will be use the end-to-end encryption while swapping. We will use the end-to-end encryption for security without trusting the intermediate nodes. If we can't trust any node, no, why attacker may be attack the intermediate nodes. For that, we will use the end-to-end encryption security for without trusting the intermediate nodes. It is nothing but a connecting two phone calls. We are connecting the two phone calls without the operator ever hearing our conversation. Our conversation can be heard by the telephone operators, but it should not be ethical. For that, the two phones are connected with each other without the operator. In the same way, we should have to make the connection between the two particles which may be never interacted with each other. Next one is the quantum memory requirement. Here we have only the three things we have to know about the memory. For memory requirement, we have only three fields. One is the coherence, is next one is the fidelity, next one is multiple qubits. Here long coherence. If there is any long coherence, must be stores the data in second to second or minute to minute. We should have to store the data in minute to minute and second to second. Why? Because if there is any coherence occurs, the data should not be lost due to any weather conditions or any natural calamities. For that, we should have to store the data second to second and minute to minute. And next one is high fidelity. It should has to test the rate of the flow. The read and write operations with below 1%. We have to maintain the quality of errors rate should be below the 1%. If there is an error above the 1%, it has a data loss. So we should have while performing any read and write operations, the error rate should be below the 1% to maintain the high quality of entanglement. If while making entanglement, the error rate should be below the 1%. And next one is multi-cubic capacity. We should must store the data in several entanglement states. We must always store the data. See, if we are storing the data in multiple locations in the cloud now, in this similar way, we should have to store the data in multiple entanglement state, which may be in parallel or not parallel to one another. To perform the operations, to perform all the operations correctly, we should store it in a multiple states, nothing but multiple entanglement states. It may be with an adjacent one. We use the technologies for quantum memories. One is the trapped ion, next one is the neutral atom, and next one is NV centers. Example, Harvard and MIT University. Harvard and MIT University in 2020-21 developed the quantum memories. They have developed the quantum memories that takes the qubits from one state to another state. Within the several seconds, there is a critical repeater operation was performed. They perform with the help of the repeater, they transform the data within the seconds. And next one is NV Center in Diamonds. It is in Switzerland. They also in Switzerland also one more deployment was happened for the quantum memory requirements. It has already in the real-time world deployment. One is in Harvard and MT in 2021, and next one is in NV Center Diamond, which is in Switzerland. And the generations of the quantum repeaters. Here presently we have only 3 generations. First one is in first generation. In first generation we will use probabilistic and experimental or basic entanglement. We will make with the help of the basic entanglement is nothing but the entanglement or swapping happened between only the adjacent pair. With the help of the adjacent pair, we have make the entanglement. While the limitations of probabilistic operations, the current experimental implementations, it has in current experiment stage. And next one is in second generation includes the error connection. We have added the error connections for expected in it should be happening within the 5 to 7 years. Includes the error connection. In first one, no error connection was in first generation. Error connection was not included. In second generation, when we are forming the entanglement swapping or memory, quantum memory, there should not be an error. It should must below the 1%. They had implemented these rules in the second generation with the help of the quantum entanglement between the adjacent and non-adjacent one. And next one is in third generation. They will fully for any coherence or any tolerant quantum operators which has been encoded in quantum information. It should be taken in 10 to 15 years. It has been 10 to 15 years for true quantum internet. With the help of the third generation, we can develop the internet, true quantum internet with the help of third generation. In each generation brings exponential improvements in readability and scalability for providing security. In each generation, we have worked on the exponential improvement in reliable security and scalability. Here the experimental range. One is 90 current we are using 90 kilometer per range for long distance quantum repeaters, and the quantum memory is in 5 seconds. Their maximum chain is in between the 3 nodes and fidelity is 85%. This graph shows that currently the range is 90 kilometers and coherence is only the 5 seconds. And we are using in between the 3 nodes and fidelity. It has an 85% highest fidelity. Here we are maintaining highest fidelity for the repeaters across the two entanglement swappings. Here technology is moving very fast. Today the lab experiment will be the tomorrow's infrastructure. We have to conduct the n number of lab experiments. Why? Because the technology has been increasing from day to day life. Why? Because we are moving from the now we are moving for quantum engineering. We are before we are using the classical computers. Now we are using the quantum. What is the vision? The vision of quantum internet. It is a global network for entanglement. It is nothing but the transmission the information with the help of the quantum internet, the global network transmitting the quantum information. We should have to it will transfer the quantum information across unlimited distance without any repeaters. We have transferred the data with only smaller distance by using the repeaters. The quantum internet was used to transfer across globally and with the help of high security guaranteed by the physics. It is not a theoretical one, which is a physically proved. Which has a physically proved, so it has to cover the global network and quantum architecture. Here, quantum architecture is nothing but first one is the application, same as our architecture application layer transport layer nodes. In the same way we have the architecture for the quantum. First one is the application, next one is the protocol stack, third one is the repeater network, and fourth one is the hardware. In the application we should have to secure the communication. We should have to secure the communication, and we are using the distributed quantum computing. It is not only in single place. We are using the distributed computing. Why? Because with the help of the repeaters we are communicating with the one node to the another node. And next one is quantum sensing. In quantum protocol we are using the protocol is called as an entanglement management. We are using the swapping between the one node to another node, one quantum bit with the another quantum bit, or one photon with another photon. We should have to manage the
Sir, sorry to disturb you.
entanglement before swapping, and there should be an zero error connection. There will be error connection. If there is any error connection, we should have to bring it for the below the 1%. And repeater network in metropolitan region and long. Yeah, okay. Hello.
Sir, your voice is not clear.
It was low. Okay.
Hello, sir, am I audible?
Yeah. Yes. Yes.
Okay, sir.
Yeah. Just now we'll take a break and we'll continue the session. It is already 1.5 hours.
Yes, sir.
We will continue the session after taking a small break.
Okay, sir. Thank you.
Okay, sir. Thank you.
Sir, I will
all
be
the-
share one link before the break. There is a small quiz about these two slides, two presentations. Can I share now?
Yes,
Yes,
sir.
sir,
Yes.
of course you can.
In between the break, they can able to solve those things. Yeah, I have shared the one Google form link. It has in 10 multiple choice questions. Please answer the questions.
Okay, all the participants, link for the quiz is available in chat box. Please click the link and attempt that.
Sir, you can
After
also share it in the group, no?
Yeah, of course, sir, of course, I will do that. And along with the quiz, please also fill the feedback form. Thank you.
Yeah, I will be back in 10 minutes, sir.
Okay, sir. Thank you very much.
Okay. Thank you so much, guys. Almost all the participants has filled the quiz form. I think I still now I got the responses around 70 plus responses. In quantum repeaters, our next topic is how the applications are security, how we will provide the security for quantum networks. How we will provide the security for the quantum networks. Here we have majorly using the three formats for providing the security for quantum network. One is unconditional secure network, and second is the quantum secure network, and third one is the distributed quantum secure network. In quantum secure network, we will make the use of QKD algorithm and multi-party computation network. Multi-party computation network, we will provide the security for quantum networks which will be protected from the attackers. We will make the use of in unconditional secure communications network. We will make the use of QKD and multi-party computation network security. By using this technology, we will provide the security for our quantum network. In quantum secure quantum computing, we will provide we will provide the blind quantum computing. We will provide the blind quantum computing. Let us outsource without losing or exposing your data. In secure cloud computing in quantum, we will not expose our data to others. We will encrypt the totally, we will encrypt the data in the quantum bits, and we will not expose our data or results without revealing any inputs. We will use the algorithm called QKD and POC algorithms. And next one is the distributed quantum sensing. In distributed quantum sensing, we will use of network sensors. We will in sensing network, we will use of the sensors for detecting the threats. Whatever the threats we will present in the quantum network, we will identify with the help of the network sensors, which are very highly sensitivity, which has the sensors are ultra high sensitive sensors. We will use the high ultra sensitive security sensors for identifying the any errors or bugs in our network. And next concept is how we are securing the in critical infrastructure. We are mainly using it is in a power grid systems and water treatment, transport and traffic systems, and financial marketing and healthcare networks. We are mainly using our quantum in power grids and water treatment plants, transport and traffic systems, financial marketing, and healthcare system. For that, we should has to protect the all the vulnerabilities from the system. We should not allow the attackers to attack our system. We should has to be very planned algorithm. We should has to plan the algorithm accordingly to protect the attacker. This system will require both security and as well as a protection. We should have to provide the guarantee for the all the systems. Why? Because everyone is an try to stole the data or from the systems. We should have to protect the data very confidently in power grid and water treatment and transportation, mainly in financial transaction. Mainly in financial transaction, we should have to not only provide the security, we should have to provide the long back protection guarantee. We can align with this, we can achieve with the help of achieve with this with the help of the quantum capabilities. Exam Example, a quantum secured smart grid can detect and prevent the cyber attacks early before they able to attack. With the help of the all these algorithms, we previously discussed three algorithms, a quantum secured smart grid can detect and prevent the cyber attackers before they attack itself. Before when they are planning to attack, it will identify the system with the help of these three security layers. One is unconditional secure communication and secure cloud computing and sensing sensors. With the help of the sensors and secure cloud computing and secure communication, it will protect the all the infrastructure before the attackers are going to attack our systems. And majorly our quantum computing is used in the major smart cities. With the help of the quantum network, we are developing the each country as in a smart city. Why? Because everyone is becoming the automation. Every device is becoming a automation. It should has to operate itself. Example, Tesla car. The Tesla car can be having an autopilot mode. It will work without any driver and it will securely reach our destination, which will provide the security for the car and the partisan. Here we have the three types of smart quantum secured smart cities. One is device authentication and second is the secure autonomous systems. Next one is privacy protection. Here device authentication is nothing but we should has to prevent the spoofing of IoT systems. Everywhere we are using the IoT sensor. It should not be spoofed. Why? Because if they are spoofed, they can able to develop the another IoT sensor which with the help of same one. They can develop the applications or they can develop the devices. So we should have to provide the huge security for that device with the help of the authentication. We should provide the authentication for the all the devices for spoofing. Why? Because the man in the middle man, it is nothing but the attackers will attack the sensor and all take the all the controls from the system. Next one is secured autonomous system. We should have to protect. It is nothing but we are using in Tesla car as an autopilot mode. We should have to protect the driverless cars and emergency systems. We should provide in emergency system. We should have to provide it. Next one is Privacy protection. Privacy is a very crucial role in every network. Why? Because we should have to maintain the privacy. It should not be data leakage. We should have to safeguard the citizens' data, whichever or what data we have collected via urban IoTs. Everywhere we have collecting the data of the customers. It should be a very priority wise. We should have to store the all the data and safeguard. It should be an encrypted model. It should be not be decrypted. Why? Because if they can able to decrypt, everyone can able to access the data. So we should have to provide the privacy for the customers. Next one is the challenges in implementation. There are lot of challenges, among them one is technical hurdles. Technical hurdles is nothing but we should have to maintain the particular room temperature for quantum systems. It is nothing but we should have to maintain the reliable room temperature for quantum memories. We should always maintain the temperature. The system should be also in the temperature of the space temperature or below 0 degrees Celsius. We should have to maintain the system in very cool temperature. Why? Because we are using the n number of transistors in the system. It will generate the lots of heat. To provide the heat protection, we should have to maintain the temperature cool. Next one is the large scale of error connection. If there is any error, if there is a large error connection, it is possible for large errors. Next one is multiplexing channels. There is a large number of entanglement with the swapping. For that, we should have to provide the multiplexing channels. Next one is the deployment. For the deployment of the quantum computers, it is high cost of the hardware. To prepare the hardware, a major thing is we require the cooling system. For cooling purpose, we should have to maintain the chillers. And next one is the chips are made up of the gold foils. It is not a silicon one, no. So that's why we should, it cost is very high when compared to our classical system. Next one is integration of the network. We can't able to integrate the our existing system with our quantum computer. Why? Because the classical computer is a different from the quantum computer. We should, if the integration is an easy, we can, the cost can be reduced. Why? Because the cost is very high when compared to the classical system and quantum system. Next one is workforce. There is a very skill gap between the workflow. Why? Because in quantum computing, we are mainly using the physics concept. It is nothing but the quantum physics. It is not a theoretical or a practical one. With the help of the physical logics, we will develop the system. Next one is the standardizing. Here we have some standard errors for the quantum. It's one is nothing is IETF. One is IETF. It is a quantum inter research group. And next one is ITU. Next one is ETSI. Next one is ISO, IEC standards. These standards have provide the security for all the architecture or system infrastructure. They provide the few standards for our system, but it is very standardization effort. To maintain these workflow, you should have to maintain all this IETF, ITUT, ETSI, and ISO, EC. And roadmap for the deployment. This is the roadmap for the deployment. USA Quantum Internet Base, and there are total 70 node of network. One is Akron, one is Primlip, Chicago, and in New York. All these are expanding their quantum computing in this with the help of 17 nodes. In USA is expanding their quantum technology, and most of the pan Europe countries are using the quantum internet. And next one is the China. China is one of the backbone for the quantum because it has launched the Mesius satellite. It can be able to communicate with a range of 2000 kilometers between the Beijing and Shanghai. Linked with it, they have the trusted node, and there is the no repeaters. Without repeaters, it can be able to communicate between the range of 2000 plus kilometers, and it has been very secure. There is no repeater. If there is a repeater, it can able to transmit the data more than 2000 plus kilometers. Without repeaters only, it is transmitting the 2000 plus kilometers. And the future timeline. Implementation time is taken from 2023 to 2025. It was the first one to 2022 pilot repeater network. It has a nodes of 5 to 10 nodes. In 2023 to 2025, they made the repeaters of network like 5 to 10 nodes. And in 2026 to 2030, there will be a regional network. It should be covered with the regions, and it should have minimum 20 to 50 nodes. By 2030 to 35, it will be a national network. It will be a national wide. It should has an 100 plus nodes. By 2040, it has a global quantum internet. There they want to quantum in globally. They want to establish the quantum internet throughout the globally within the time period of 2040. Organization should plan now, and they are too long risk falling for our blind. Why? Because with the help of these technologies, they can able to access our classical system very easily. So we should have to face the consequences after 2040. And security and planning recommendations. Here, one is an established strategy. Here, established strategy is nothing but we should have to create a roadmap for creating the quantum security integration between our system, our classical system, and we should have to communicate with the quantum system also to provide the communication between the quantum system and provide the communication between our classical system. We should have to ready with our strategy, quantum strategy. Why? Because we should have to communicate with the normal system and quantum system. Next one is an infrastructure assessment. It is nothing but we should have to provide the fiber networks and repeaters feasibility. With the help of the repeaters, we should have can be able to communicate with the large range. Next one, partnership and pilots. Collaborate with the quantum test based. We should have to collaborate with the quantum test based and research institutions like in USA, America, sorry, USA, China, and European countries. Many European countries are working on the quantum. We should have to make the partnership with the quantum leaders globally. Has China, we should have to make the partnership with them. Then we can able to acquire the quantum networks to other countries also. Next one is the security skill development. We should have to train the security engineers in quantum info science. Why? Because now we are training all the engineers in the AI mode, AI and machine learning, but upcoming one is the quantum. So we should have to train our junior engineers in quantum engineering. And key takeaways. These are the quantum repeaters are essential for extending the quantum technology. We should have to have the quantum repeaters are essential for scaling the behind the 100 kilometer to transfer the data above the 100 kilometers. We should have to use the quantum repeaters are essential. Next one is tech, tech is an advising rapidly. Technology is advising rapidly. First commercial deployment is in within the upcoming 5 years. The deployment of the quantum system is within the upcoming 5 years, and we should have to provide the applications are transformative to cloud, IoT, and infrastructure. Applications are transformative to cloud, IoT, and infrastructure. Next, we should have to plan must now. Why? Because we should have to integrate with the all the system. There should be integration with all the system. It will be takes in a years. In upcoming years, we can able to integrate with the quantum systems. Quantum internet is just not a internet. It has a faster internet. It has a whole new security features. Why? Because they are using the QKD algorithm and PCOS algorithm and many more. This is for this one. And next we have the how we are using in digital era. Previously, we have discussed about quantum cryptographies and quantum repeaters. Now we will discuss about the quantum cryptography has moved behind the labs to critical industries. Now the quantum just in the not in the lab practicals, it was for the real time implementation also. In this session, we will explore the landscape and deployment across all the sectors, how the quantum engineering was implemented in all the systems, or like all the financial industries and future challenges. We should see the future challenges and how it was real world we are using the quantum engineering. In these slides, we are going to learn about the quantum threat landscape, and next one is the real world deployment, next one is the financial sector, how we are using the quantum engineering, and next one is challenging and future outlook of the quantum engineering. Why quantum cryptography is now? Before we have only the classical encryption like RSA and ECC encryption techniques. We have only using the RSA and ECC encryption techniques that will be breakable in 5 to 10 years. That will be breakable in within the 5 to 10 years with the help of the quantum computing. It is nothing but it has using the Shor's algorithm. One more algorithm is called Shor's algorithm. With the help of Shor's algorithm, we can easily encrypt the RSA and ECC data. It is breakable in within 5 to 10 years. And next one is harvest now and decrypt later technique. Next one is harvest now and decrypt later technique. With the help of that, we can store the data. We can store the encrypt data today and we can decrypt in later. As the data is coming, we can be stored in a store with the help of HNDL and we can decrypt after later. We can able to decrypt the data in later. In industries already under the pressure, many industries are under the pressure with the help of the quantum engineering like defense, finance, and healthcare system. Why? Because all the all the financial algorithms organizations are using RSA and ECC algorithms only, but they can able to breakable by with the help of Shor's algorithm. If Shor's algorithm is implemented, every computer data can be they can able to attack. So it is feasibility. Next one is how the regulations are happening. USA White House 2020, all the agencies must adopt the PQC algorithm. They are using the PQC algorithm for securing all the data in USA, and European countries are using DORA algorithm for crypto agility. They are using the DORA algorithm. It is nothing but Digital Operation Licenses Act. They are using the Digital Operation License Act in all the European countries. Example, China and Russia, there was a cyber unit are suspected to stockpiling encrypted NATO data for decrypting. For decryption purpose, China and Russia are using the DORA. And the current state of the quantum cryptography. What are the current states? We have already previously discussed in the first session. It has a quantum key distribution key. Next one is post quantum cryptography and hybrid approaches. Here we will use of the photons to exchange the data securely. In QKD, we will use of the photons. We will mainly use the photons to exchange the key securely. Here, one more is an vendor ID. Vendor ID should be an unique and it should be exchangeable. Here, vendor ID is an unique. We should maintain the unique ID for the vendors. Every vendor has to maintain the unique ID. And coming to the post PQC, there is a quantum computer. There's a quantum computer for algorithm resistance. We should has to new algorithm that should be resist the quantum attacks also. For even though some attackers may possible to attack the system, no, so we should has to develop the new algorithm to resist the quantum attacks also. They are using the NIST standards to prevent them. Next one is the hybrid approach. It is nothing but combining the classical and quantum algorithms. It is nothing but RSA and QKD algorithm. If we must should be combined with the these two algorithms. Why? Because without this, our classical systems can able to attack easily Attackers can attack on our classical system. Why? Because they are using the shorts algorithm. Shorts algorithm is implemented. They can able to attack on our systems. Example, Google Chrome and Cloudflare are tested by the Kyber PQC. Kyber PQC algorithm was using by the Google Chrome and Cloudflare certification on live internet in 2022. In 2022 itself, Google was conducted a test with the help of the Kyber PQC algorithm. With the help of Kyber PQC algorithm, they had conducted the test in 2024 internet connections to provide the security and real world deployment communication network. Coming to the real world deployment, one was the China. China is the one of the backbone for the quantum engineering. Why? Because in 2017 itself, they has launched the satellite for first international quantum encryption video call. They had made the first quantum encrypted video call in between the China and Australia within the range without using any repeaters. Why? Because it has launched the QKD algorithm. It has been using the QKD algorithm and it has distributed the all the keys in between the Beijing. And operation is since 2017. It has launched the satellite in 2017. Now they are using the quantum communication globally globally. And majorly they have communicating with they had made the first video call between the China and Australia. And next one is the European countries. Many of the European countries are using the quantum networks with the help of the 5 nodes. They are using the 5 nodes. The countries are including in the Europeans are Netherlands, Switzerland, and Germany. Germany and Switzerland are also using. In 2019, Switzerland was launched his QKD algorithm for transfer the data within the range of 100 kilometers per banking transaction. For the purpose of banking, it has using the QKD algorithm within the range of 100 kilometers to communicate between the one bank to another bank. But nowadays, all the European countries are using the quantum theory. It is nothing but bank, government, and telecom. In all the areas, they are already using the quantum engineering. Next one is quantum cryptography in healthcare. Here, healthcare, we have to maintain the one is we have to maintain the patient's data, and next one is the research thing. We should always store the patient's data and research scholar data researchers in system. For that, we should have to provide the security. Here we will use the NYC uses the quantum resistance encryption. They use the there is one hospital in China, Mount Sinai Hospital. It will use the quantum resistance encryption. It will be using the quantum resistance encryption for storing the patient data for longer time. It has a n number of records. And next one is medicine to store the medical data to store the telemedicine security. Japan healthcare provides a QKD for securing video consultancy. When we are communicating with the video call, we should also provide the security with the help of QKD. They are providing the video call security for the hospitals in Japan. And next one is the medical research. European research hospitals are using quantum security channels for sharing their sensitive and clinical trial data across all the borders. They want to share all the data, clinical trial data between all the across all the borders. So they are using the quantum cryptography itself. Next, we are using in defense and government applications. USA has using the DOD. It is a Pentagon-based QKD algorithm. They using the Pentagon-based QKD pilot algorithm in 2021. And other one is the NATO. NATO is also using their quantum algorithms like QKD. It also using the PQC protocol for securing alliances between wide common communication. To perform the wide communication, they are using the NATO is also using the PQC protocol. And next one is the Australia. They are using the hybrid encryption for embassies. For the embassy, Australian embassy, they are also using the QKD algorithm for hybrid quantum classification encryption. And next one is UK GCHQ. It is one of the leading research into an lattice based. It also using the PQC algorithm. What are the benefits of using the quantum cryptography? By using quantum cryptography, what we are getting? It is nothing but providing the security. It is not as a mathematical or not a theoretical one. It is completely based on the physical concept. So no one can able to attack our data. So it is providing the security for our data. Next one is the future proof. It will protect the data for the decades of time. Why? Because there are n number of random numbers are generating with the help of the quantum photon. The photon has an n number of random numbers, so we can protect the data for the large time. And next one is detection. Sorry, detection. Here detection is an nothing but alternating photons. There should be a communication between the alternative photons instantly. We should have to communicate with the adjacent and non-adjacent photons while transferring the data or while communicating with the each node. Where because if we are using the repeaters, each time we should have to communicate between the adjacent and non-adjacent nodes. So there should be a communication between the each node. And there are some compliances. It may be new cyber security regulations. It should be new cyber security regulation. Before we have the RSA, now we are using QKD. For that, we should have to maintain some compliances. For the attacker should not has to attack, and we should have to maintain some policies for that. And challenges, major challenges is one is the cost barrier. Before only we think said that one is the major problem is cost barrier to develop the QKD hardware. QKD hardware system, it cost around the 100K dollars. 100K dollars per each endpoint. For each endpoint, it should require the 100K dollars, and it has to be maintained a new infrastructure. The existing infrastructure we can't able to use. We should have to develop the new QKD hardware setup. We should always need a new infrastructure. And one more is the technical limitations. Why? Because to develop the quantum repeaters or to develop the quantum system, we should require the more people in. We should have to train people more on quantum engineering in physics wise, not in a computer manner. We should have to explain all the theory and practicalities of photon energy and quantum things. It will be why? Because it is completely physically based, not only mathematical and theoretical. It is completely based on the physics. So we should have to there has some technical limits. Why? Because everyone is now on the computer technologies. They are learning all are learning the Java or any languages. But now we should have to focus on the physics while developing the quantum systems. And quantum repeaters are still in experimental only. They are not implemented practically. Why? Because the China itself launched the one of the satellite just without any repeater. It is transferring the data more than 2000 kilometer range, but there is no repeater. It is the only concept. Now they are working on the quantum repeaters. And one more major task is integrating with our existing system. We can't able to integrate our classical system with the quantum system. Why? Because the quantum system is different and it has our classical system is different. Our- the quantum system we should has to maintain in the very low temperature, and we should has to provide the cooling chillers. And next one is the practical hurdles. It is not a standard. Now only they are standardizing the all the quantum principles like ETA, NTC, and NEC. But we should have to standardize all the things to implement it. And one of the major thing is performance overhead. Next, we have to have the supply chain constraints. Despite all the challenges, critical sector are moving for implementation. They to implement the quantum system, it has a very outweighed of the cost. to implement quantum system, we have to bear the huge amount on the development of system. Why it was mainly used in the financial aids? Why financial aids are used? The reason is, first one is the bank process trillions of transaction daily. In financial sector, it plays a major role. Why? Because always the bank will process the trillions of transaction daily. The attackers may target the tar- target on transaction. To provide for the transaction, we should make the security. For by base with the help of the QKD, we can able to provide the security for all the banking transactions every day, minute to minute and second to second. And next one is data contract statement. Next one is the data contract statement must remain confidential for more than 30 years. If the customer data is there in our system, it should be protected for more than 30 years. And next one is for regulating the pushing PQC adoption. Here PQC adoption is now only adapting. We are using PQC cryptography technique. Majorly we are using QKD only. Now we should adopt the PQC cryptography algorithm. Example, ECB and Bank of England are already working on the QKD for the settlement of system settlements. The bank in England Bank and already using the QKD algorithms for all their transactions daily. And next one is the banking application. Here, a number of transactions were occur from daily. They are based on the quantum resistance authentication. For authentication, now we are using mobile authentication and password or OTP. Next, they are using upcoming days. They are using the quantum resistant authentication for mobile and online banking transactions. To perform any online and mobile banking, they are going to use quantum resistance for authentication. And for intra-banking communication, to communicate between the intra branches, to communicate with one bank to another bank, they are using QKD. Why? For it is used in the first session. We also used QKD for sharing the data from one data center to another data center, or to making the connection between the one data center to other data center. We are using the QKD. It is nothing but for physically collaboration with one bank to another bank. We are using QKD. And next one is data protection. Here, quantum system will provide the high security for all the financial data centers. Why? Because already the data centers are using the QKD, and moreover we are working on the PQC algorithm also. They are also going to implement both these algorithms. With the help of these two algorithms, we are providing very secure for banking transactions. And now they are working, many companies are working on. JP Morgan and Bank of America and HSB have announced the quantum security initiatives for pilot projects already. They are working on the as a pilot project. They are working for the quantum engineering and quantum computing to implement these two algorithms. One is QKD and next one is PQC algorithms. Swiss Bank also using quantum network for the implementation. Why? Because it detail is 100 plus kilometer fiber network. They are connecting for major Swiss bank. Major Swiss banks are connecting with the help of the fiber network with the help of the quantum. It is operating since 2019. 2017 was launched by the China, and 2019 Swiss Bank is using. And each time the ID will be unique with the customer for banking the protocols. And to transfer the secure transactions, they are using the QKD algorithms. And they will perform the one minimum. They are using $15 million for quantum. And the key features are key rotates every minute, every 5 minutes. Every 5 minutes, they will be keys are rotated, and they are using the hybrid crypto for cryptography. Next one is the physical tamper detection. There is any physical tamper detection, it will be easily identify with the help of the quantum random number generation. And JP Morgan also using the JP Morgan company also mainly working on the quantum base. Why? Because it is a one of the major banking sector project. They lead with the major banking sectors. They are also working on the quantum engine. As a result, they have transmitted 1 billion quantum secret messages during the sixth month trial phase. They have started in 2020 and now they have completed 1 billion transactions with the help of the QKD. With the help of the QKD, they are performing the banking transactions. They are also very successfully implemented the QKD in JP Morgan and stock exchange and financial marketing. In stock exchange and financial marketing also, we are using the quantum engineer. Example, Tokyo Stock Exchange. Stock Exchange was implemented the QKD in 2021. They are using to connecting primarily for the backupping all the files. For backupping all the files, they are using the QKD networks. Please be on it. And London Stock Exchange also using the QKD algorithm for testing the to generate the random numbers for traditional system and post quantum cryptography. They are using the all the three algorithms in London Stock Exchange. One is QKD and one is the random number generator. Next one is the post quantum cryptography also for stock exchange. Here stock exchanges are created based on the quantum security. They were prioritizing all the security with the help of the quantum security and to protect the marketing strategies. It will always protect the marketing integrity and security and prevent the manipulation through cryptographic attacks. Why? Because in the stocks, everyone are ready to invest in the stocks. So many of the transactions are occurring in the stock market also. They should have to provide the security before the attackers attack. It will also protect the attackers wherever they are attacking. Next, one of the major is global pay. It has using the payment networks. Through the payment networks, is using also using the quantum technology. Example, Visa and Mastercard. Visa or Mastercards are implementing the quantum resistance algorithm for tokenization and transaction purpose. For verification of all the transaction, they will always generate the token. They are generating the tokens with the help of quantum resistance algorithm. Visa and Mastercard, one of the major global cards everyone were using. They are also providing the security for the customers with the help of every time they are tokenizing their transaction with the help of quantum resistance algorithm. And next one is Shift Network. Shift Network also using the QKD as a pilot between the major financial hubs. It has implemented this QKD in one of their major financial hubs, not only locally, just now they are trying to implement all over the regions. Firstly, they are using in their financial hubs for the as a pilot project. Next one is central banks. All the central banks are also want to use the quantum security for their internet banking. Now all are using the internet banking to provide the security for central bank digital currency. And one more thing is we are using the digital currency now. So to provide the security for the digital currency, they are using the quantum security for internet banking, and they are using the algorithm as a post quantum cryptography for longer time. They has to store the customer data for the many years. So they are using post quantum cryptography. Not only QKD, they are also using the post quantum cryptography to store the long term monitoring and stable purpose. And next one is the blockchain security. Also digital assets and blockchain security is also using the cryptocurrency. Now one of the famous thing is the cryptocurrency. They are also using the quantum technology. Financial institutions with crypto custody service are implementing the quantum resistance. They are also implementing the quantum resistance security schema to protect all their assets, to protect the security for all the assets of all the financial cryptographies are using the quantum computing, and they are using mainly the post quantum security wallets are JP Morgan and Fidelity. JP Morgan has already implemented. It has a trial run of the 6 months. They are using the quantum security and they have delivered the 1 billion of messages directly. And next one is the quantum resistance smart contract. and it has used by the Goldman Sachs research. These researchers are also using the quantum resistance for smart contracts and hybrid classical security systems for cryptography exchanges. There is a cryptographic currency. To exchange the cryptographic currency, they are using hybrid classic quantum security as a digital asset. Here the time is, it is estimating it will be take 3 to 5 years for quantum computer to threat blockchain security. To provide the threat and for the blockchain security, it will take for 3 to 5 years. Next one is the challenges in finance sector. What are the challenges if we implement in the quantum security? What are the challenges faced by the financial sectors? It is one is the technical, next one is the operational level, next one is the business level. Technically, we should have integrate the PQC into the global based banking core system. We should have to integrate PQC in all their global banking system. Why? Because they are using the our traditional system. We should have to integrate our PQC into their systems. And next one is the operational. In operational level, we should have to certify the security. We must and should certify the security at the scale of million customers. Why? Because million customers of data were with there in the banking sector, and they are performing trillions of transactions daily. So we should have to certify the security at the first level. We should have to certify the at first level itself. Next one is the business. There is high migration to migrate their business from the traditional system to the quantum computers. It may be the high cost for migration. Why? Because we should initially only we said that it has a takes a high cost. Why? Because it should we have to maintain the temperature. We should it we are chips are made up of the gold, not by silicon metal, and performance is also overhead. We should has to train the each expert in quantum technology. Why? Because all the engineers has to be trained. If we shift from the traditional system to the quantum system, we should have trained the all the engineers for quantum technology. And future development. Future development is in upcoming 2023-2027. What they are going to implement. NIST is all they are using PQC standardization. They are also going to implement PQC standardization for NIST for all the financial sector as a pilot project. For the many of the financial sector, they are using as an PQC standards. PQC is using as going to be one of the standardization by NIST. Next one is the 2022, 25 to 26 regulatory mandate begins. Why? Because every bank has to be maintain the quantum resistance payment network. Before we are using normal payment gateway network. Now we should has to use quantum resistance payment network. And 2024 to 2025 quantum resistance TLS for banking and commercially for QKD for cost reduction. For TLS banking, we are using quantum resistance, and for commercial, we are using the QKD. Why we are using QKD? For the cost reduction purpose. For cost reduction purpose, we are commercially using QKD. And 2026 to 2027, there is a quantum secured CBDC launch. To interact with the each rotational system, we should have to launch the quantum secured CBDC launch. Financial institution that wait all the regulatories are required and finalized. We should have to maintain all the standardization. After the standardization, every organization is going to use the quantum computing itself. They will not going to anymore not going to use traditional systems. Why? Because if the quantum engineering is implemented, they have a Shor's algorithm. The Shor's algorithm will easily able to track all the system data. What are the key takeaways? Here, beyond the theoretical, quantum cryptography has moved from labs to real world. Before it has in the lab only initially, before 2016 has started the explanation about the quantum cryptography. Now the China has already launched the system, and many of the organizations are also financial organizations of JP Morgan and Swiss Bank is already implemented at the trial runs in quantum cryptography. And financial leads. Financial leads like banking and financial institutions are at the forefront of the quantum for security adoption to provide the more security for the all the transactions which are happen trillions of transactions daily. They are using adapt. They are going to adapt the RSA quantum security adapt. Sorry, with instead of RSA, they are using quantum security adoption. They are moving every financial banking institutions are going to quantum security adoption. Why? Because there are huge number of transactions are occur daily to provide the security and to provide the privacy for the customer, the information they are using quantum security adoption. And next one is the hybrid approach. Initially, one of everyone is using only the QKD, and the hybrid is nothing but the combination of the both PQC and QKD in realistic path. We are in hybrid approach. We will use both the algorithm. Now all are working on the QKD only, but in future, everyone is going to implement or everyone wants to combine both the algorithm to provide high security. It is nothing but PQC and QKD in realistic path. And next one is the agno. It is because of higher cost and high risk, many of the organizations are not working on the quantum engineer. But in upcoming days, every organization is going to implement the quantum engineering in their sector. And next step for the finance sector to provide the security for next 6 months, they should have to conduct the quantum risk assessment for each critical system. They should have to conduct the why because they are only in initial stage. We have to conduct the assessments and we should take the how risk was with the help of the quantum. If there is any risk, we should have to identify. And next one is next 12 to 24 months, we should have to train the teams. We should always train our teams with the we should have to implement some budget for all the trainers to train on PQC and CDK algorithms and how to deploy the all cryptographic algorithms. We should also train. Why? Because all are on traditional network only. Now we are moving for the quantum technology. So that we should have to in coming 12 to 24 months, we should have to train our team and we should have to budget some amount for the PQC and QKD. Why? Because it is huge cost. We should have to plan a stat. We should have to plan very clearly. Why? Because budget plays a major role in quantum engineering. And the financial system is the first battlefield of the quantum era. Here, one of the major industry is going to lead is financials is an financial system itself. Financial system is the first battlefield for quantum era. All the banking sectors and financial organizations are using the quantum engineering. There is one more quiz. I will share the link. Please try to participate in that also. So just now I have shared the one more link for the session 2 quiz. Please share it in the WhatsApp group so that they can easily access that.
Sure, sir. Sure, sir. All the participants, please click that link and submit the quiz. And feedback link for the second session is also available. Please submit that one also.
Is there any queries? Can I share the all the presentation to you, sir? Is it required?
As participants, if you have any queries, unmute yourself and you can ask the speaker.
Serious, sir? Do you require the PPTs?
Yes, sir. I require PPTs because some of the students, participants requesting. Please share to my personal ID. I will share it to the group.
Yeah, okay, sir. I will forward to you and please forward in the group also.
So shall we close the session, sir?
Yeah, yes, sir. Before that, please copy that link and share in the WhatsApp group, sir, so they can access.
Yes, yes, yes. Yes, sir. I will do that. I will do that.
In
I
the
will
end
do
of the meeting, the link will be not, not in chat box.
Yes, sir. Sure, sir. Sure, sir. I will do that. I will do that.
Okay, sir. Thank you, everyone. Thank you, Shreya, sir, for giving this wonderful opportunity.
Thank you very much, sir. I would like to sincerely thank our esteemed speaker for sharing his valuable insights and enriching our understanding. It is truly been an engaging session, sir. Very much good information you have provided. Definitely, it is helpful in our career as well as in our future research endeavors. Thank you very much, sir.
Yeah, thank you, sir. Thank you so much.
All the participants, please submit the quiz as well as feedback form. Once submitting, you can leave the meeting. Thank you very much.
Thank you, sir. I'm leaving the meeting.
Feedback form and quiz is also available in our WhatsApp group.